Now next topic, polar and non-polar molecules in external field. See, we already discussed this thing. Polar molecules possess permanent dipole moment and non-polar molecules does not possess permanent dipole moment. But if we think about the non-polar dielectric substance, therefore entire substance the net dipole moment will be zero because each molecule have the dipole moment equal to zero. But for polar dielectric substance, each molecule possess permanent dipole moment. But here, due to thermal excitation and random orientation of all the dipole moments, if we take the vector summation of all the dipole moments, the net dipole moment of the polar substance, that is also equal to 0. But when these substances are placed in the external field, then both the substances will get some net permanent dipole moment. How? See, if external field is 0, then for non-polar molecules, center of positive negative charge is superposed and it does not possess dipole moment. But if it is placed in the external field, then due to the force on positive and negative charge, these centers of positive negative charges will be displaced under the effect of this force of external field. And now each molecule will possess some dipole moment, or we can say for each molecule the dipole moment will be induced. So here some net dipole moment will be obtained. Similarly, if we think about the polar molecules, then each polar molecule have some dipole moment. But due to random orientation of all these, the net dipole moment of the substance, that is 0. But in the external field, again the positive charges will experience the forces in the direction of the field, negative charges will experience the forces in the opposite direction of the field. So all the dipole moments will try to align themselves in the direction of the field, and due to that again you will get some net dipole moment. Clear? So if non-polar or polar molecules are placed in the external field, both will have some net dipole moment, or we can say some net dipole moment will be developed in both type of substances here. Right? Now suppose we think about the case of very low temperature, and in that particular case, if we think all the dipole moments are perfectly aligned with external field, then see, in this particular manner all the dipoles are aligned here. Now here what happens? This positive negative, this positive negative, this positive negative will nullify each other. So in this particular case, here at this particular surface, some net negative charge will be induced. Here we can say this surface charge density, that is minus sigma p. This alignment of all the dipole moments along the electric field, that is called polarization of the molecules or substance. Okay? So when the substance is polarized, here on this side the negative surface charge density due to polarization will be developed, and on other side the positive surface charge density will be developed due to polarization. Clear? Now the dipole moment per unit volume, that is called polarization P. Here dipole moment induced, or we can say some net dipole moment is induced. So the net dipole moment per unit volume, that is called polarization P. And here for linear isotropic dielectrics we can write P, that is chi E, where this constant is the characteristic of the dielectric, and that is known as the electric susceptibility of that dielectric substance, or we can say dielectric medium. Clear to all of you?